In this video, you will learn how to build a full-stack app using Angular and ExpressJS with Datastax's cloud NoSQL database Astra DB. The features will include list events, create event, and filter events. The web app will be a single page with search at the top followed by the form to create the event, and then below those forms will be a list of the saved events. The web app you can see behind me is a single page app with search at the top followed by the form to create an event. Below both of those forms will be a list of saved events. The web app will load the list of events over a REST API using a GET request, which is the same for the search form as well, but will have a query parameter. When submitting a new event via the form, the web app will post a RESTful request to the API, and the API will save the body of this request in the database. By using these open source tools such as MVC frameworks like Angular, Material UI Design, RESTful APIs, and NoSQL databases, you will be gaining a foundation for making most web apps, allowing you to create your ideas into real projects. To complete and make the most out of this tutorial, the following will be required: installation of Node.js on your computer, and create an Astra DB account, and you can log in with your Google or GitHub account. It's completely free. In this next section, I will provide a brief explanation and description of the tools we're going to be using. For example, what is Angular? Angular is a front-end framework that allows developers to write once and deploy to multiple platforms. Learn one way to build an application with Angular and reuse your code and abilities to build apps for the web, mobile apps, native mobile apps, and even native desktop. Angular is not to be confused with AngularJS, which was version 1. Version 2 and above was completely rewritten from the ground up, and in my opinion is really awesome. Learn more on the Angular website. What is Datastax's Astra DB? Datastax built a data API gateway into Astra DB, so app developers like you and me have an idiomatic JavaScript API stack that works great with the Jamstack or any other front-end stack of your choice. Astra DB is built on top of the rock-solid NoSQL data engine Apache Cassandra that powers Netflix, Instagram, Yelp, iCloud, and so many other apps we use every day. Cassandra and Stargate are open source projects. No surprise, this is me. So how do you connect to Astra DB? Well, there are multiple ways to connect and work with your data. For example, you can connect over a REST API over HTTP, GraphQL, or CQL, Cassandra query language. In this tutorial, we'll be using Astra DB's document API and AstraJS's JavaScript library. So why use Angular, Express, and Astra DB together in the first place? Jamstack providers can make your app globally available via a content delivery network, CDN, or edge network in seconds. And you've gone from desktop to the cloud, worldwide deployment anywhere. But what about the data? That's where Astra DB gives you its perfect companion to the Jamstack apps, as it brings your app at a commercial internet level of scale, reliability, and performance on any cloud using straightforward JavaScript. So what is ExpressJS? Express is a library to build back-end REST API apps. Express is a minimal and flexible Node web application framework that provides a robust set of features for the web and mobile applications. With many HTTP utility methods and middleware available, ExpressJS creates a robust API really quickly and easily. You can learn more about ExpressJS on their website. If you're not aware, Angular uses TypeScript, and you may be thinking, what is TypeScript? Well, TypeScript is JavaScript with syntax for types. TypeScript is a strongly typed programming language which builds on JavaScript, giving you better tooling, especially as your project grows. To give you an example, TypeScript provides early benefit. If we take a look at this code here, for example, we have a constant user object with first name, last name, and role. And if we try to console log name, instead of waiting for us to run the application and run the code and test it, TypeScript will already let us know that this property does not exist on this object. And that is really useful, especially when your application grows, you're working across multiple files and multiple people. This is really helpful. It does look very similar to JavaScript, and in fact, you can write standard JavaScript, and TypeScript will try to infer the type from the existing code. And if you want to be super strict, you can also use interfaces and add more types. But don't worry, we're going to keep things quite simple in this video. You can learn a lot more about TypeScript on their website, and they also have a playground where you can actually play with TypeScript in the browser. So we're going to actually build the front end first, and we'll hard code data, and then we'll build the API and hard code data. Then we'll connect the database to be real dynamic data through the entire app. So let's create the front-end application first. Angular has a CLI, a command line interface, where you can actually initialize apps, scaffold things really quickly straight from the command line. And to install Angular CLI, you need to use the command npm install -g for global Angular CLI. Once you've done that, you'll have the ng command install, and you can type ng help and get a whole list of the commands available. In our case, we're going to do ng new, and then we'll give it the name of our project. Let's answer some questions that it's asking us. Do we need routing? We don't need routing in this app, so we can say no. Are we going to use CSS, SAS, SCSS or less? We'll just stick with CSS because we're going to use the material design framework. And now it's going to create a folder and install the dependencies and create the project for us. If you're enjoying this video so far, don't forget to give it a thumbs up and hit subscribe below so you can get notified every time I post a video and go live. Now it's been created, let's navigate into our directory that we created, which was video, Angular, Express, DataStax. You can call this anything you want. So now we're in this directory, we can see we've got some files in here. So let's open our favorite IDE, VS Code, and let's have a look. So let's see what files it's created. So we've got node modules folder, which you're familiar with already. We've got a source directory, which we'll come back to in a second. Let's have a look. So it's got Angular config, it's got our package.json, and a few other files. So let's open the source directory and let's see what we have. So we have our index.html, but also in the app directory, we have one component that we're going to be using, and you can break this down into subcomponents yourself. Let me know in the comments below how you break this up. It's really interesting to see how you all split this out into subcomponents. But to keep things simple, we'll just keep it in a single component for now. And in Angular, a component is made up of really just two files. One is the HTML, and this has some CSS in it. And we'll load the project in a second so you can see what it looks like. And then also a TS file. And the TS file supports and has the logic for the HTML file. And the HTML and TS file communicate together to send data between each other. Let's run the app and take a look. So we can do npm start. The first time you run this, it might take a moment longer. So now it's done that. It says we can open it on localhost 4200. So let's go have a look at that. So now you can see this is the default Angular app that you get. So let's clear all this, and so therefore we can get working. Behind this is the TS file. It's got title, and it's given us title of the project. We're not going to use that, so we can remove that and save, and you will see that it automatically reloads, but it failed because we're using variable at the top and we've deleted it. So let's go to the HTML and let's remove all the HTML, and let's just write the usual hello world and hit save. Now compile, we've got hello world. So we've still got our Angular app, it's still running, but now we're customizing it. And it's always important to check as you go along that when you customize it, that you check it still works. So I'm happy with that, that still works. So the first thing we wanted to do is list events. So let's hard code this and check it all still works. So we'll say events is the title of the page, and underneath that we're going to use a standard unordered list in HTML. And then the first item will be event 1, and we'll do a comma, and then we can put a date, so we can say the 1st of Jan 2021, and then we'll need a URL. So in this case, we could say edihub.org. Let's just create a second event, and we can say it's on the 2nd of January, and that URL is, say, edijal.io. Let's hit save. It will automatically refresh the browser, and we can see that. So we've got it displaying the front-end UI code in the browser. Just to quickly recap, I have made changes in the HTML file so we can visually see what that looks like in the view in the browser. And I encourage you to make your own changes. This is a great way to learn. I know this doesn't look very pretty. We will style this up with material design later on to make it look nicer. So let's get a bit of dynamic data. Let's create the API and get the front end being driven by the API. This will allow us to move the hard-coded data from the UI to the API. And this will then allow the UI to be updated dynamically from the API. And then at a later stage, when we update the API to connect to the database, the front end won't know anything different, and it will still work exactly the same way. So usually we would have two repos for these two types of projects, one for the front end and one for the back end. Or a mono repo where you have two subfolders in a single repository and they're completely separate, a front end and a back end. But because we're only going to have a single back end file for our project, I'm just going to put it in the root of this project. So what we need to do next is install ExpressJS. And the way you do this is do npm install express. And then if we go to our VS Code, in the root of the project, let's create a file called server.js. In our server.js file, let's import Express. And then we'll also want to create the app. Thank you very much, Copilot, for helping me out with that. And we will require cores because our apps are going to be working independently on different ports. So we want to allow connections from the front end. So we're going to do it so that we allow anything to connect to our API, and also we want to use the middleware of ExpressJS so it converts all the communications into JSON format for us. And that's mostly config, so how can we actually write an API endpoint? Well, we can go app, and we can say, is it a get, is it a post, or is it a put? A get is when you're requesting data. That could be a list, it could be a single resource, and it could be a filtered list, like doing a search. Post is when you're creating data, so you're posting data. This must contain a body. A put is when you're updating an entire object. So if you've got a user object and you want to update every single field, but some might be omitted, and that means you want those fields removed from the database, you would use a put. But if you want to update only the fields that you send through, you need to use a patch. And there are other methods like delete, if you want to delete a resource. And we can return hello world when this endpoint is requested, as also completed with Copilot. And then we'll get the app to listen on the port, and we'll get it to put in a console log so we know it's running. API started. So if we hit save, we could do node server, but to make things a bit simpler, let's go to package.json, and into the script section, let's add API, and then we'll say node server.js. Let's save that, and if we go to the terminal here, we can go npm run API. We should get an output, API started. We were expecting that because that's what our console log was. I made an error. I made the path to be events. I actually want the path to be /. Now if I refresh, I need to restart the app because we haven't got NodeMon rebooting the app for us. So we need to load the new code into Node. The way we do that is Control-C to stop it. I just pressed up to restart the app. Now if we hit refresh, it's going to work with Hello World. This is why I keep saying check it each step as you go along the way. You don't want to spend hours doing all this work, and when something goes wrong, you don't know where the mistake is. So now we can actually create another endpoint. So let's keep that Hello World one. We can make sure the app is working. Let's create the events one that I was doing a moment ago, and we can hard code some data into this. We will want an array back, and we will want multiple objects. So let's, at the moment on the front end, we have 2 objects coming back. So let's do 1 or 3 to make sure that it is different. So let's have a look. The data that we will want, we'll put an ID in, and this isn't going to be the final ID, this will be the ID from the database, but we'll put one in now to keep the data structure the same. We will want a name and we will want a date. So we could say the 1st of Feb 2021 to be different to what we hard coded in the front end. We'll also need a URL. So let's leave it as one event for now, hit save, and it's automatically formatted for us. Thank you very much. Don't forget to stop your app and then run it again. And now if we go to the browser, this hello world isn't going to change, but if we put events at the front, we now get our event. Look at our JSON, it looks really good. I am using a plugin in the browser, that's why it appears pretty, otherwise you'd probably see it like this. And then if we go to the front end, nothing will have changed because we haven't connected the 2 together yet, but we are going to connect both together. So currently we have the hard-coded data in the web page, and we need to connect the front end to the API. Even though we also have the hard-coded data in the API, the front end will not know the difference when refactoring the API to connect to the database. This is because the API will return the same data structure. The benefits of starting off with the hard-coded data in the first layer, the UI, is that we can focus on getting immediate feedback that the app is working. Automated testing would be really great here to do, but this is a discussion for another time. And then when building the second layer, the API, we can check this works independently, giving us confidence that when we connect the 2 layers together, the app will still work as expected. This building and testing the layers independently will save us time and by reducing bugs. So how does the Angular front-end app connect to the API? Well, Angular has a HTTP client built in, so there's no need to research and trying to pick the most popular one of the week. All we need to do is import in our app module, the file, the HTTP client. So we go back to our code, and if we open the file browser on the left, we have an app module file that we haven't looked at yet. But this is where our components get loaded and also where we import Angular modules too. So in this case, we will want to import HTTP client module, and we'll need to import it at the top as well. And to get access to this in our component, this module, we would use the constructor. Angular has really good dependency injection. So if we want to use the HTTP client, we would give it a variable, HTTP, and then we would say the type that we want, in this case, the HTTP client. But to make this variable available to the class, we can put a private in front of it. That means it's not available to the HTML, but it's available in this file. And when we put private in front of it, it makes it a class variable we can access in other methods that I'll show you shortly. We mustn't forget to import the HTTP client. It is better practice to put the HTTP client and calls in a service file, but again, to keep things simple, as we're not going to have that much code, I want to keep it in a single file for now in the component file. Being TypeScript, is really nice to have an interface, a structure for our data. So let's just create one in this file. And again, usually this would be in its own file as well, but we'll keep it in here for now. We're gonna have an ID and it's gonna be a string. And then next we will have a name that will be a string, and then we'll have a date that will be a string, and we won't have a time, but we will have a URL that will also be a string. So how is the HTML gonna access the data? Well, we will have a public variable called events, and it's going to be of type event, which is an array, and then it's going to have a default value of an empty array or an empty collection. And so when we update this class variable, it will automatically update in the UI, in the HTML page. So let's add a method called findAll, and in here we're going to make a HTTP request to the API. And you can see Copilot has done a pretty good job of auto-completing that, but let's type it out. So we would go this HTTP that will allow us to access the class variable HTTP that we have in the constructor up here. And then we want to perform a get, and we want to perform it to the URL HTTP localhost 3000. That's what the API is running on. And we actually want to go to the path events. Angular uses RxJS, so we want to subscribe to the event. It's a bit like a promise, but much more functionality. So we're going to subscribe to that. We're going to have the events returned, and again, it's going to be a type event. You could leave that off for now as well to keep things simple. What we want to do next is save the events data into the class events variable. Therefore, the HTML can be updated and display that data. So let's have a look. So we could say this.events equals events. And with TypeScript being strict and saying that the type of data I'm expecting isn't the one that matches in a subscribe, well, it is. And so I need to tell it with a generic that I'm expecting event data, so cast it to that format, and therefore it knows the rest of it is going to be correct. And a lot of the time with JavaScript, you don't put this in, you just kind of hope that it matches and it's correct and it works. And if it doesn't, you put all these console logs everywhere to try and figure out what's going on. So this might look harder, but trust me, it is actually easier. So I am expecting that data. I know I'm going to get it back. So therefore here, I could omit this and leave it off because it's already inferred, which means TypeScript should know what it is. But to be a bit more verbose, I'm going to leave it in for now. We want this to fire the trigger every time this component is loaded. So we could just go this findAll. So every time this component is loaded and the constructor is loaded, every time the class is instantiated, it will run this. It will go get the data and populate it into the class variable. What do you think? Will we see something different on the HTML page? Well, we won't, because we haven't updated the HTML page to use this data yet. Very simple change. The hard part is over, I promise. So we'll go here. We'll delete this line, so therefore there's only one li because we're going to loop over it. So what we want to do is do ngIf, so we want to check to see if there is data. And if the data exists in the events and it's greater than 0, then let's loop over the data. And the way we do that is with an ng-for. And we'll say let event of events, and then in here we can replace these with the actual data that we want. So here it will be event.name, and then here it will be the date, so it'll be event.date, and then it will be the URL. So we can go, you guessed it, event.url. So now if we save this and look at it, we can see one result, and that result matches the API. So let's update the API and just double check. So let's put a second event in the API. We're in the server.js file at the moment. I'm going to give it an ID of 2. We will say event 2 and we will say the 2nd of Feb. I'll leave the same URL. I'm going to save this. We must remember to restart the backend, restart the API. You can install something called NodeMon, which checks for file changes and does that automatically for you. But as we don't plan to make too many changes, I'm not going to throw in more tools into the mix just for now. But any questions, leave them in the comments below. So now if we go back to the front end and hit refresh, we now have 2. And if I go to the browser tab that has the API data, we also have 2. So you can see now the front end is connected to the back end, connected to the API. So when we refactor the API to work with the database, the front end doesn't need changing. It will not know any different because it won't know if the data is coming from hard-coded data on the API or from the database directly. So now let's actually create the database on Datastack so we can actually get real data persisting dynamically. So the first part of the database integration will be to get the data, and we need to manually insert some data. So when we query for it in our code, there are some results. Otherwise, at the beginning, it's going to be quite empty. If this is familiar to you, you can jump ahead, adding the form and create the data directly from the front end, which we'll do shortly later on, but I wanted to finish off the get first. So what you need to do is log in to Astra DB, and I log in with GitHub, but you can create an account or you can log in with Google. It's still the same, it's still free. You get $25 a month credit free per month, which I really struggle to even use a fraction of that, even with all the demos, videos and coding and projects that we have from EdiHub running on it. It's a very generous tier. So to create a database, you then click on Create Database, and you give the database a name, and then you give it a key space. And a key space is kind of like a namespace. It's an area where you make a collection of tables or collections. So therefore, you could do it per client, per project, and I think that's really awesome. You can put them in a database. And then after that, you would choose a provider. So you can host this on Google Cloud, AWS, Azure, and then you can even choose the location. So if you wanted North America, Europe, and I think this is brilliant. So now that you've created that, it will take a few minutes to get created the first time, and you'll have an orange on the left here while it's creating that. So going back to what I was talking about, the key space, if I go to my YouTube database, I have different key spaces where I have my Next.js video, my React.js video, and we have an Angular video. And you may be thinking, how do I connect to the database? Via curl or via the browser or via code? Well, when you click on your database, you can go to connect, and it'll actually give you examples down the left, document API, graph API, REST API, and different languages and SDKs that you can use. And as you click on each one, it automatically pre-fills the information you need. If you have multiple key spaces, it will pick your first one, so remember to change that. And then the token you can create from the organization section. So here you can create as many tokens as you need, and then you can give it different access and different roles for what you want to give it access to. I would say give it the minimum amount of access that it needs. Don't try and give it super user admin access, and if it accidentally gets compromised or you commit it by mistake, then you're giving someone access to more of your database. So here are the ones I've created earlier, and this is where you would put the token. And you can export these into the terminal, so you could use it with your curl commands. You could also use environment variables or env libraries, and you can do this in various different ways. Make sure you don't put this directly in your code and by mistake commit it to GitHub on a public repo. Let me show you how you can create data in your database just by using a curl command. You can also use Postman. Datastax does have Postman configuration already preset, so you can download that and add it to your Postman, and then you get all the options available to you already done. You just need to update your tokens. As I mentioned before, we can communicate with Astra DB using curl. So here's a curl command from their documentation that you can see behind me. And I've already got these environment variables set, so therefore you can't see my private tokens. So I'm just going to add a name, date, and URL, but not an ID as we did in the hard-coded data, because that will automatically be generated by the database. So we could say this is event 10. It's going to have a date of the 1st of March, 2021, and it's going to have a URL of very, very exciting localhost. I mustn't forget, data is a string, so I need to wrap the JSON data in single quotes. So now we've created the data and we know it's been created in the database because we've been given a document ID back. When we connect up the API to the database now, we should actually get an extra result. And you can create as many of these in your database as you want, but don't create too many because we're going to do it via a form on the website. I want to show you how you can retrieve and save data in the database with just a few lines of JavaScript. So what we need is to install Astra.js collection. So npm install Astra.js collections. And then next, you'll need to export the tokens, as we mentioned before, and the other environment variables needed. Make sure you don't commit these to your code. And then once you've done that, we will require the Astra.js collections in our API. That's now finished installing. So here at the top, we can include it. And then next we need to connect, so we need a client. So what we do here in this function events, and we'll move this out later so it's reusable, but for now we can keep it in here. We're going to say create an Astra client, and we're going to use the environment variables that we use for our curl command, so they're exactly the same. As you can see, this is really, really straightforward. And then next, we want to access the namespace, which is the key space, and the collection. So we can do this to make it easier, so we don't have to keep writing this each time. So we'll use the Astra client, and we'll get the namespace. In our case, the namespace was Angular video, and then we'll want the collection, which we have called events. And then all we do now is use the find. And the find, you can use different operators, and we'll get to that later on. So for now, we're just going to use a find with an empty object to return everything. Copilot completed that for me. But one thing you'll notice, we're using an await now, so we mustn't forget to put async at the top of our function as well. Side note, from the Datastax's docs, it is not recommended to have no where clause, as a find all will return all rows from all partitions. Luckily, we're using the JavaScript library from Datastax's that has a default limit of 20, but it would be safer to add a where clause for any future changes in the library. There's one thing that you will notice in a moment, so let me show you. So if I return this data, instead of the hard-coded data, if I return events, hit save, mustn't forget to restart the app. So let's run our API again, go to our API tab in the browser, and now you can see we've got 4. So we've got events that I created earlier and the one we created today, which was event 10, which we created together. Remember, I had a local host and it was on the 1st of March. But what you'll notice is this returns an object, not a collection. And the ID is the key, not a property in the object. So we just need to slightly do some bit of manipulation over here. So what we can do, we can say object keys, and we'll take it from events, and then we'll want to map over those. That's correct. So we want to map over each of those, which will be an event. We're going to turn this into multiple lines because we also want to return the ID as well. So what we can do here is we will say, we'll do a return, and we want to return the ID, which will be the event's key ID, or actually in this case, it is just the key. And then we want to return the event object. So we'll spread it, and then we'll select the key out of it. So just to recap, what we've done is the data that you see here, we want to grab each one of these objects, take the key of it and add it into the object itself. So it looks like the data we had before. So what we're doing, we're using JavaScript's object keys function, and we're putting it on events, which is what we got back from the database. We're going to take the key of each one, set it as the ID, and spread the rest of the object so it merges the two together. So let's hit save, let's restart the API, and let's have a look how it looks. And now you can see it's been turned into a collection, and the ID is now a property on that object. So it looks perfect. If we go to the front end, what are you expecting happens? I'm expecting that it will read data now from the database because it won't know any different if the data is hard-coded in the API or coming out of the database. Let's do a refresh, and now you have 4 items. So if I went back to here and did another curl command, because we haven't got the form yet to insert data via the UI, we'll do that shortly. And if we come here and actually insert event 11, yeah, we're on 11 now, and we'll say it's the 2nd of March. And so we'll change that to 2nd. I stop the app to run the curl command. So if I run the app again, We've got one more here already, and if I refresh the front end, we've also got number 11, it has also appeared. We're not doing any sorting at the moment, so their order is appearing a bit random. So now we've got data coming out of the database, the full stack application is working. Let's add a little bit of styling. I suggest we add a material design, but you can add Bootstrap, Tailwind, there's loads of examples out there. And I'm going to use the Angular CLI to add it for me, make it a lot easier. Ask us what theme we'll like, we can just pick any one. We'll go for pink and blue and gray. We'll go defaults all around. Now that's done, you can see the page got reloaded, the font has changed slightly. So we need to import some of these modules that we've just installed as a dependency. And you know how to do this. This is in the app module file. If you go to the Material Angular website, so you know what you want to import, you can say get started and it tells you how to use it. We've just done that command. But also if you look at the components, it shows you what is available from badges, checkboxes, form fields, snack bar, tables, loads of things that you can do. So what we want to use is we probably want to use the list and the icon, and we will eventually want the input and the button. So let's bring those across now. So I'm going to put them all in one go. So in the imports, I'm going to import quite a few things. So mat list from material design, because it's got mat at the front, mat icon, mat input, mat button, and then forms module is for Angular forms. But we must also import these up here as well. So we'll bring the imports for the mat items, and we mustn't forget the Angular forms as well, because that's what we're going to do next. We're going to do the forms. So if I hit save, it'll reformat it for us. So if we go to our HTML file, we can start using the material design components. We're still going to need the if, and we're still going to need the for loop, but we're going to need it on different types of items. So in this case, we want mat list. We're still going to do the check. We don't want to display the list if there's no data. And then we want to also, for each item, we're going to have a loop over that. And then each one's going to have an icon. I've just got the folder icon for now. You can change this to whatever you want. And then we're going to have the name, then the date, and then URL. So if we hit save, let's see how that looks. So as you can see, it's already starting to look a lot better. Next, we want to add a form. We will want it to, on submit, be submitted, but we will need to actually get the data from the form. So this will be a form create, and then on submit, we will want to send the data from form create dot value. And then let's just close the form so we don't forget, but we will now add the fields that we want. So using material design, we'll say mat form fields. And then we want it to have a label, so we can do mat label. And the label in this case can be name. So next we need an input, and then we will give it a directive of mat input, and then it's going to have a placeholder. And then we'll also give it the field a name of name, and we'll let Angular know that it is a model as well. But on submit doesn't exist yet, so we should actually create that, because otherwise it does fail. So let's do that for now. So we can say on submit, or we can say on save. Let's say on save, let's make it descriptive. On save, we're gonna have the form data, and let's just do a console log for now, but we will be sending that to the API. So now we've added a single form field. Let's see how it looks. And what I've also done is I've actually given us a dark background for our app. So let's take a look. So it's automatically reloaded. You can see these are the events from before, and now we've got a form field. But what you'll notice is we haven't got a submit button, and we're missing some other fields as well. So let's go and add those now. So we've got this, we will need another field. If I duplicate that, we are going to need date, and we are also going to need URL. And then we will need a button as well. So in this case, we can do button raised color primary. Awesome, Copilot, thank you so much. That's great. Hit save. Let's have a look at this form. It's all in one line. I think it looks really good. The top labels match the button as well. That's coming from the material design themes. So if I open the console, because we have in our code, when we call the onSave, we have a console log. So let's have a look. So let's just say name 1, date today. I know it's not the correct date, but we're not going to save this in the database. And we'll just say localhost. Then just a bug, form create needs to equal ng form. I thought I had that in there already, but I probably missed it. So we will have name 1, date today, and URL, we can just say localhost. It's not going to save it, but we should see a console log in the console, and we do. So the details have come through, so that is working. So this console log is working, it's great, we've got the data, we now need to send it to the API, but also the API doesn't handle posts yet. So let's quickly add that on right now and just see how straightforward it is. We can just do app, post, and we're going to have it on the same endpoint, on the same path, which is events. It will eventually need to be async, so let's just include that now. We'll get the request and we'll get the response, and Copilot had that completed well for us. And then here, let's just console log the data that we've got coming in to make sure it's correct. Oh wow, you can see it's auto-completed from us. Pretty good, not perfect, but we will write it ourselves. So we're gonna leave the client off for now, we're gonna leave all those, but we will just return the body. So we can say res send, and we can return the information we have coming through, which is rec.body. So let's just return that. We can also console log it as well if we wanted to see it in the terminal, and we can do rec.body. So we save that in the API. Must remember to restart the API server. So stop and start. And now if we go to the component on the front end in Angular, we can actually send this. And you know how to do this already. So do race ahead if you want to. It'll be this HTTP, and this time it's gonna be a post. And we're gonna go to the exact same URL. So as it's auto-completed for us already. And then we will wanna subscribe to the data that's coming back. And we can append it to the list, or we can console log it. There are quite a few things we can do. Oh, it's already completed for us. It's gonna say, it's gonna take the event coming in and its event type, and it's going to add it, it's gonna push it on to the events collection that we have. So let's save that and give that a go. So we've done event 11, 10, 3, and 2. So let's jump straight to 20 to make sure it's completely new. So event 20, and we will say it's going to be the 1st of Jan 2022. And the URL can be my YouTube channel. It got added to the bottom, but it didn't get added by the data we got sent to the API. It's the data we got sent back. So it's looking really promising because we send data, but we grab the event back. So it looks like it did go end to end, still without the database, but it's looking pretty promising. So we can check this in a couple of ways. We can go to network, we can click on this, on events, and we can see that on the headers it's a post, this is the one we want. And we can see that at the bottom, the request payload was what we sent, and that looks correct. And preview is what comes back, and that also looks correct. So we can also check the console log in the API, and we see that. So it looked like it worked pretty well. And if you want to do any extra checks, you can. You could always add an ID here, just a hard-coded one to check it works. But I'm pretty confident that's working. Let's save it in the database and make it work for real, properly, from end to end, from the front end, the API, and the NoSQL database. So again, we would need to connect to the client, but we'd copy and paste this, but it'd be duplicate code. So we can actually abstract that out and have it up here. So what we can do, we can create a constant, and we'll say the client is equal to an async function, and in this function, we are going to connect. This will allow us to reuse this code. And actually we can include the collection in there because we're not gonna have multiple collections. But you can always pass it in as variable. There's various things you can do. So then what we can do next is return the collection. And to check that all works, we can check this here. So we can say const collection equals await client. Let's save that, and we can test by refreshing the page and make sure the data is returned. Yes, the latest one we added got removed because it's not stored in the database yet. So we know that the get's working with abstracting out that client call, and so therefore we can use this in the post as well. So it's going to be very much the same. We're going to say const collection, and we're going to do an await for the client. And then if we go to the documentation on Datastax, you will see it's so easy to create the data. We did the find that I showed you earlier, but now here's the create. We don't want to give it an ID, we want to automatically generate it. So we can just use the create and pass in the object. So here we go, we can say collection.create and pass in the object that we want, which is request body. I do recommend pulling out the items out of the body that you want. Don't just send everything straight to the backend. Do your sanitation, do your validation. But for this simple example, we will leave it how it is. So we're going to pass back the body, and then what we'll get back from the create is actually the ID, if you remember correctly from our curl commands. So if we bring up the terminal, you can see here we get an object with a property document ID, and that has our ID, and we want to pass that back. So we can create another constant, and we could say document, and we could put equals to that. And then in the request body, what we can do is we can pass in an ID, which is going to be the document.document ID, and then we can spread the body as well to send that back. So let's hit save. Let's remember to restart the API. Hit refresh, still looks pretty good. Let's create a new one, make sure it is added, and when we refresh the page, it should still remain, it should still be persisted. So on this URL, it should work in any browser. So let's have a look. So this will be event 20, and the date will be the 1st of January 2022. And we can say, again, my YouTube channel here. So this didn't get persisted before, but should get persisted now. Hit save, it is there. So now if we refresh, it still remains. It has jumped around, so you can see it's bumped up one. We haven't got any ordering on, but you can see it has persisted on the refresh. So it's definitely gone to the database and definitely come back. So that is our full stack application, but I know you want more. So let's create some operators and see if we can search the data. So let's add an additional form, and we know how to do that quite easily. So we can say let's add an additional form on top. We're gonna be form, we want ng on submit, but we're not gonna call it on submit, we're gonna say on search, and then we want to pass through form search and the values. And we mustn't forget to create the local variable search, and that's going to be ng form. Then inside here, we can cheat and copy one of these. You don't have to type it out again. I know you're eager to work on your own projects as well, so we will need a button though. So let's do this. This won't be name, this will be search, and then the placeholder could be keyword, and it should be keyword, not work. And then it could be keywords. And then let's copy the button as well from down here. So now if we save that, it's going to break because we haven't got the search. So like we did before, we can write a search function. So we can say on search, and we are going to have some data coming in, and it is going to be of type form data. But this time we will do a get. So we could do HTTP, and it will be get, and we'll be getting a collection of events back. It won't be on the URL search, it will just be events. So Copilot got it a little bit wrong that time. So URL will be events, and then we want to pass in some parameters to go with the get request. And we want the parameters to go as params, and we want the data object to go, and we can spread that, and then we can subscribe to the events that come back, which will be very similar to the find all, but it will be a filtered down list. And data's complaining because it needs a type. So in this case, just to keep it simple, I'm going to write any, and you can reduce and relax your notifications and how strict it is, or you can use any. I don't recommend it. I think it's important to use types, but for this simple example, I'm just going to use any. And now if I hit save and save the UI, that will reload and look correct. However, you've got search at the top. However, the backend doesn't know what to do with it. So what we need to do is actually on this get, we need to do a condition. We could create a separate endpoint, but I think it's simpler if we just have a condition. So let's just check the keyword we're sending, and we're sending keyword. And so on the back end here, when we get a get request to the events, what we can do before we do the find, we can say if the query, not ID, but if the query keyword exists, then we want to run a different query on the database. So what we'll do is we'll define events up here. We'll say let event equals an array. And then here we'll remove the constant definition because now we've got two. And then we can write this line here and say events equals, we still want to await the collection, and we're still going to do a find, but in here, let's do an equals. If we go to the DataStax's documentation, in the where clause, we can do equal, not equal, greater than, less than, in, and not within. You can do all those sorts of things. So in this case, we're just going to use equal to keep it simple because we're doing a search. So we can say find name, and then it's going to be a nested object where it's equal to the query keyword. So we do the check if the keyword exists. If it does, then we do a find on it. And then if it doesn't, we do a find all. So therefore, we've got the same endpoint catering for the full list as well as search. Let's save that, restart the API, head over to here. And if we do a keyword search, let's have a look. So if we search for something that doesn't exist, we should get no results back. And we got no results back, so that's correct. So if we reload the page, let's say we search for event. They've all got different names, but so we should only get one result. So if we say event 11 and search, we should only get one result back. But let's add another event 11, but put it on a different date. So the one that exists, you can see, is the 2nd of March. So let's say it's going to be on the 2nd of June, and the URL is the same, for example. And if I hit save, it gets added to the list. Let's do a refresh and check that it's there. It is there. So now if I do another search for event 11, you can see now we've got 2 results, 2nd of March, and the new one we added 2nd of June. Oops, I forgot the year off on that one. You can see how easy it was to filter your data from the dashboard. We managed to create a full stack application with not that much line of code in the front end, not that much code in the back end, and persist it to a NoSQL database in the cloud. The where clause can use any of these operators as applicable to the data type defined. The storage schema used by the document API indexes all values, so columns can be used with an operator. So let's summarize what we've built. We've created a full stack application using Angular for the front end, ExpressJS for the API backend, that's a RESTful API, and DataStax's Astra DB NoSQL database using their document API that displays a list of events which allows the user to create new events as well as filter the list. It's straightforward to get started with Angular, Express, and Astra DB. Here are some actions for you to try. Move these sections into components. You could move the forms into their own components. You could also add an edit button to the list so we can edit the events. And to do an update on the API with Datastax's Astra is really straightforward. It's only another endpoint and line of code. Don't forget to share what applications you build and technologies you use with the EdiHub community. Also, if you build in this example, you'll be eligible for Datastax's swag and spotlighting both in EdiHub and Datastax social media channels. Look forward to seeing what you build. Leave a comment below and let me know what you thought. Of course, give this video a thumbs up, and I'll see you in the next video and live stream.